Okay, hi all. So this is a demo lecture for Industrial Engineering GATE Examination 2026. Okay, so we'll start with the Industrial Engineering subject and we'll understand the topic of break-even point. And before that, we'll see what are the terminology we have to understand. So if I talk about the industrial engineering, so I'll go through the step-by-step points and terminology to understand and crack the gate examination. So we'll start with the production. So if you know what is production, it is nothing but a step-by-step value addition process from converting one form of material into another form in order to increase the utility of the product by the user. For example, if I have an object, let's suppose if there's a car which I have to manufacture. So to manufacture a cars, I need a raw material, something like engine, and before that I will need a lot of requirement to form an engine as well. Even if I have to build an engine, for that I would require so many raw materials that will form and do assembly, and then I'll get an output. So to form an engine, basically, I would need to go a step-by-step addition process by converting one form of material into another form to increase the utility of the product. So if you bought a piston, you can't do anything with the piston until unless you develop a cylinder piston and then you develop a whole engine, then only it will be form a utility product which can be used by the user. So input can be anything, and all the input will form a conversion. We do some conversion process, and then we got the output. An output is something which can be used by the user. So in the production, you can be have production of anything. For example, iPhone, iPads, laptops, cars, rockets, engines, anything, or aircraft, whatever it is. So to form a useful product, you need to go a one by one process, and that's how you need to do. That's how the production is. It is a step by step value addition process. So each step you are adding some value to the product. If you're forming an engine, so let's suppose a IC engine I'm talking about. So we need a piston, we need a cylinder, we need a casing, we need a valves, we need a spark plug. So each by step we are adding a value to that product, and that value will finally increase the value and can be used by the user. That is called production. And what is production system? It is an organized process converting raw material into the final product with a feedback loop. So now, to do the production process, I would require all the systems should be in line in the process, right? For example, if I have to make an engine, for example, if I talk about a gas or make an aircraft, let's suppose if I have to make an aircraft, I cannot do by simply getting raw material and build an aircraft. It's not possible. So it should be an organized process. For example, wings will be developed by some other company and get it done by them. The windshield can be developed by some other company, engine can be developed by some other company, and whole body can be developed by some other engineer, some other company. Tire can be built by some other company. So to get it done, so it is basically an organized process by converting again a raw material into a final product with a feedback loop. And feedback loop is nothing but it's a kind of monitor loop. So production system is an organized process by converting raw material. Raw material could be man, material, machine, etc. Okay, and this input will go to a conversion process, and we got the output. But in product, this is what it's production. But production system having a monitor output. So here, there's a monitoring will be happening, and then they will compare the actual versus desired. So let's suppose if I build a nut, right? And now I'm checking the nut quality. Is it a good quality or not? Is it a bad quality? If it's a good quality, then we will take it as an output and it will go to some other place where it will be required. If it's a bad quality, then they will see whether the nut will be as per our design. If not, then it will go to the adjustable needle. There basically see why we are failing this to build a nut. What is the issues coming up? So they will feedback is basically will help you to build a model in a better way. That's the idea. So production system basically again it's an organized process. We are converting raw material into final product with a feedback loop. If I talk about the productivity, so productivity is basically a quantitative term. I mean, for example, if we talk about the efficiency is a quantitative term. It will tell you how efficient our system it is, right? Similarly, productivity is a quantitative term. I mean, it will tell you what we produce and what we use as a resource to produce them. For example, we took aluminum sheet as a raw material and converting into a let's suppose a cylinder or a piston cylinder arrangement. That is an what is our output, right? So every organization wants to increase the productivity by applying techniques and methods. So productivity is basically, it will tell you how quantitatively you're improving your product, right? So again, it's a quantitative term. It will help you to tell how good productivity you are doing, and it could be output by input or input by output, depends on the organization how they are making up. If I talk about industrial engineering or industrial engineer, what does industrial engineer do? What is the job of industrial engineer? So the job of industrial engineer, if you are, let's suppose tomorrow you have to set up a factory of, let's suppose you want to set up a factory for electric bike or electric car. So the industrial engineer job is to design an installation of all the improvement production activity there. For example, if let's suppose if I have to build a car of electric car, then as an industrial engineer, I should make a battery pack very near to where production is happening, right? Because if I'm making a battery at North India and building a car assembly in South India, that's a very bad industrial engineer, because that will increase your cost. So the job of an industrial engineer is concerned with the design, installation, improvement of production activity. Whatever production activity is happening there, it should concern with all the production activity should be streamlined, right? And the engineer works at a broader level and optimizing entire system involving people, material, machine, information, energy. So everything is being managed by industrial engineer. Again, if you become an industrial engineer, then your task is basically to build a facility layout where you will assemble all your cars, electric cars. You will prepare a work study where you will get to know that each assembly how much time it will take time. You will also manage the supply chain, whether your lithium ion is coming on time, and again the plant design, because that is very important, because you have to design a plant such a way that all the assembly are in very near to your location, right? So that's the job of industrial engineer it is. And what about the production engineer? If production engineer is there, what is the role of production engineer? Production engineer concerned with the planning manufacturing process. So now production industrial engineer has set up the plant and facility he has set up, and he also put the machines, he also put the man, everything he has set up, right? Everything he has set up, material, man, people, material, information, energy, everything is set up. Now to build up machine or to build a car, production engineer would be required. So production engineer will do a planning. So there is a planning engineer who will do the planning at how and all the material will come at what time. These are done by planning people, and then he will do the manufacturing part. He will know that the if any material to be manufactured has to go on so many manufacturing process, such as it will go from milling process, then it will go, for example, if any product built through casting, he will focus on the casting part, then he will take to the machining part, then the final product will be used at some other location. So all this information, all this activity is controlled by production engineer. I mean, this the person for the production engineer ensure the production line run efficiently and safely and cost effective. There should not be any breakdown in the machine, right? If it's happened, then production engineer should be accountable. What are the key tasks? So again, production engineer will tell what are the machine that you need to select, tools, what are the tools you have to select, and what are the equipments you need to use. All this happening on the shop floor operation. So we have on the shop floor is nothing but a huge area where all the machines are happening, and all the operation is taking simultaneously. It is a shop floor operation. So these are the difference between industrial engineering and production engineers. So if you're going your career into this field, then these are the majorly job profile that you would be looking at. And to be specific, industrial engineer mainly comes from the management department. The management department will take care of the industrial engineer, and production comes from the engineering background department. But as a mechanical engineer, we should understand what industrial engineer are doing, work are doing. That's why we have this subject, and that's why we have to study this subject. And our focus only for the GATE examination to simply attempt all the question correctly. That's the whole idea. Now, if I go into the cost of production, what are the costs involved in the production? Okay, so there are so many terminology we need to understand step by step and understand what are the cost involved while doing the production. So, for example, if you're making an electric car, let's suppose, it's not simply that whatever, let's suppose if you are buying a car of like 10 lakhs, then it will have all the cost inside associated with it. For example, this raw material cost is there, the manpower cost is there, the wherever this they are assembly, the land, the electricity, the manpower, salaries, watchmen, everything cost will be included, and we need to understand each and every what are the cost, technical cost that we need to understand. So cost in production is nothing but the total money spent to convert raw material into finished goods. That is the cost of production. Now, what are the costs involved? One is the direct cost. So direct cost is nothing but which are directly tied to making the product. For example, if I'm building an engine, then what are raw material? All the metals which are used are the raw material. What are the labors which are assembling the engine? Their cost and their expenses, and what are the machine we are using. So direct cost involves basically as your production goes, your direct cost also increasing. That is the direct cost. If I talk about the indirect cost, it is nothing but a factory overheads, factory expenses are the indirect cost. These are necessary costs, but not directly linked with the product. For example, if you have factory overhead costs, it's nothing but the machine maintenance, electricity, factory rent. So if you set up a machine, the machine maintenance has to be done regularly, but you cannot, because this has to be, let's suppose you have annual maintenance machine, annual maintenance happening. So annually one time you have to spend the money, but you cannot add that in the cost of production because one time yearly you are spending. But again, that is a cost that you are putting into it. So you need to identify how many machines, how many cars you are building up by that annual maintenance come up. So based on that, you will assess the cost. Similarly, electricity will be required. Again, electricity is again, let's suppose it's for a factory, it is a constant, right? For let's suppose I'm using 10 units. For 10 units, this much electricity will be consumed. If I'm increasing, the electricity will keep on increasing. Similarly, a factory rent. So these are you cannot directly put this cost into your cost of production, but these are the indirect costs and these are very necessary costs. But again, not directly linked to one product. Similarly, we have administrative cost. All the salary of supervisor, managers, this has to be taken care by administrative cost. Similarly, if we have a selling and distribution cost as well. So let's suppose if I make a product, how can I sell it? I need to do some marketing. I need to do digital marketing. I need to do packaging. I need to do shipping. Everything, whatever costs associated with the marketing are selling of distribution cost. Because without that, you cannot sell the product. Then we have a factory cost. What is the factory cost? So factory cost is nothing but your direct cost and the factory overhead cost. So your direct cost is nothing but which is associated with the cost, and you have your factory overheads. So addition of this cost are called factory cost. So if you see if you labor that this is factory outlet, like that banners are there, they are basically trying to explain that this involves some your direct cost and your factory overhead cost, right? This is the idea basically, but it's not like that. They will keep on adding more profits and margin and administrative cost, everything. So in our terminology, factory cost is nothing but direct cost and factory overhead cost. What is the total cost? What is the total cost we are getting? Total cost we are getting is factory cost plus administrative cost and plus selling distribution cost. If we add all this cost, then we have our total cost, right? This is our total cost. And what is selling cost? Selling cost is nothing but this total cost plus profit. We will get our selling cost. We add, let's suppose for example, let's suppose my direct cost is, let's suppose 100 rupees of making one cell phone, and my factory overheads means machine maintenance, electricity, I'm paying 50 rupees. So my factory cost is nothing but 150 rupees. Now I need to understand my total cost. Let's suppose I'm paying a salary of supervisor of 50 rupees, let's suppose, and my selling distribution cost is 25 rupees. So my total cost again will come 150 plus 50, which is 200, and 225 rupees, right? And if let's suppose I'm putting a margin of, let's suppose 10% or 20% margin, whatever it is I'm taking, so I will put on my total cost. That's the whole idea. So if I take a 25% margin, then my profit will be 56 something, and my total cost of the selling product will be nothing but it will be 281 rupees. So now if you see, when you are building a product, your cost is 100 rupees, and finally you're selling at 281, which includes only 56 rupees of profit, and rest are your cost involved by associated costs, are different associated costs which you have considered for building the product, right? So this is majorly idea of identifying the different cost. So direct cost, indirect cost involve factory overheads and administrative and selling distribution. Factory cost is nothing but your direct cost plus your factory overheads, and then you have total cost, which involves your factory cost plus administrative and selling distribution, and then selling cost including total cost plus profit. Okay, good. So now we'll just understand what is break even. Break even is a term, or is a terminology which will tell you that by selling this much amount of unit, you will be at no profit and no loss condition. So it is an important tool used by production manager to analyze potential profit or loss possible in future. So let's suppose you set up a unit by putting 1,000 rupees, right? 1,000 rupees you have put a capital by investing all the things. Now you let's suppose sell of 281 you have sell, right? 281 rupees you have the cost of this 281 rupees for 1 unit, right? So let's suppose to find out, so let's suppose how many units, let's suppose x is a unit, how many units you have to sell such that you are at condition of no profit plus no loss. Okay, you're not even getting profit and not you're at loss condition. So that is a condition of break even, analysis break even. So it's a tool basically. It will tell as a production manager, you would understand, okay, this much unit I need to sell so that I would be in a condition that I would not getting loss and not getting profit. Because if as a production manager you would understand that this much unit if I'm producing, then you would be at this condition. But you cannot go below that, because if you know that you will be at loss. So the idea is they should know that, okay, this is the point, this is the number of units that I need to sell it so that I would not be at loss condition. Okay, so total cost. So in break even, so if we understand the break even point, and we have to understand what is the break even point, and we have to calculate what is the number of units. To understand all these things, we have three terminology that we need to understand. One is the total cost, which we have already seen, but here total cost we are saying that it indicates expenditure required in order to produce certain number of units, that it's a sum of fixed and variable cost. So what it's saying that the total cost will include that the fixed cost we know that total, what is, if you're selling one goods at this much is the fixed cost you need to pay. For example, rent you need to pay, salaries you need to pay, this is fixed cost, right? And we have your variable cost. Variable cost is associated with your number of units. So this is your total cost, right? Fixed cost plus variable cost. Now if you understand fixed cost is nothing but the cost remain fixed or constant irrespective of volume of production. How much your volume you are producing, it doesn't matter. Your cost remain fixed. It includes the cost of machine, rent, salary watchman, hire officers, insurance cost, setup cost, advertisement, interest. These are the things that, again, it doesn't matter how much you are producing. If you're not producing, still the cost will be there. So if I plot a graph, so it will be, if your volume of production is increasing, your cost is constant, because you need to pay salary, you need to pay rent, you need to pay electricity, you need to pay insurance costs. Everything is constant irrespective of how much volume you're producing. But if I talk about the variable cost, it costs directly and proportionally with the volume of production. So if my volume of production is increasing, my cost is also increasing linearly. And it includes direct material cost, direct labor, and running cost. Okay, so these are variable cost. As it increasing linearly, and this is a variable cost basically. If I go to the notations of the break-even point and break-even analysis, so we have X, which is a fixed cost in rupees. Then we have X, which is number of unit produced, how much units I'm producing. For example, nut, if I'm doing 100 units, then it's X equal to 100. Selling, this I'm noting as selling cost. Selling cost is basically I'm united at rupees per unit. So for example, if my selling cost is 100 rupees per unit, and let's suppose my fixed cost is 200 rupees. Okay, now we have a variable cost. Let's suppose I have 50 rupees per unit. Variable cost is again whatever the cost associated in the total cost. Okay, and total variable cost will be nothing but your variable cost per unit into number of unit, right? A number of units. So let's suppose I am making units of 100 units, 1000 units I'm making, right? So my total variable cost will be nothing but 50 rupees into 1000. That will be 50,000, my total variable cost. Similarly, if my total selling cost will be 100 into 1000 units, which will be 1 lakh rupees. So I'm making a product for 50,000, I'm selling it for 1000 rupees, right? This is the whole idea. So total sales, basically, this total selling point, or S, is nothing but total sales. Total sales, how much selling for one cost per unit multiplied by number of unit you're selling, that is the total sales. The total sales is nothing but delta into X. It indicates the return obtained by selling out the quantity produced and directly proportional to the volume of production. It's similarly as variable cost. But in this, you're selling, you're not making. This is a selling cost. Okay, good. So if we go again to find out the break-even point, now my whole objective is to find out that what is the number of unit I should sell so that I should not be incurred losses. That's the whole idea. Okay, for that I'm doing this all the process. To understand all this break-even point, these are my assumption. So my assumption is my fixed cost, my variable cost, and my selling cost is fixed as constant. This is my assumption that my selling cost, which is 100 rupees per unit, and my 50 rupees per unit is constant. And also my fixed price, which is 200 rupees, is also constant. And whatever I'm producing, there's no defective part. There's no defective in all the produce that I'm producing. It's a good quality product and all will be sold out. My third assumption is quantity produced, all will be sold out. That's my third assumption. Okay, to follow all this assumption, now we should understand how to identify the break-even point. So if you see the graph, my y-axis is the cost and my x-axis is the volume of production. Okay, now we have one fixed cost, which I've told you that this is your fixed cost line. Okay, which is constant. As you increase the production, it doesn't matter. Your next is your variable cost. Variable cost is, if there's zero, if you're not producing anything, then variable cost is zero. As you increase your variable cost is keep on increasing. So variable cost is basically involved in this line. I mean, there's no variable cost we have plotted as in this graph. So there is only fixed cost, and we have a total cost which is over and above a fixed cost. Total cost, we have fixed cost multiplied by your variable cost. Correct? So we have one total cost line, one fixed line, and your selling point is your total sales is your S into X, which will say you're selling per unit multiplied by number of units, that is total sales. Okay, as you see, this slope will be more than your total cost. That's why you will get some profit. And this point where you will intersect your total selling and total cost point, that will be point of break even point. So this is your break even point where you will, if you sell this much of units, you will incur no loss, no profit. If you sell more than this, you will be in profit. If you sell less than that, then you will be in loss. Similarly, if I project this point on my y-axis, this is the BEP sale. It's nothing but the amount of price or sell you are doing. If let's suppose if I do a sale of 1000 rupees, then I would be at situation that I will be having no profit, no loss. If I'm selling less than 1000, then I will be incurring loss. If I'm selling more than 1000, then I will be in profit. So it's a very good tool. So to identify if I'm building a business, so I should know, okay, my target is to at least sell more than 1000 rupees, or I should sell around 50 units, so that my target, I should not incur any losses. My target will be fixed in that case. If I go over and above, I will get the profit. So BEP is nothing but break-even point sale, and the point where total cost equal to total sales. This is the point when total cost is equal to total sales. This is the point of break-even point. So organization that point neither earn profit nor loss, and this is also known as no profit no loss point. So now my total sales. What is my total sales? Total sales is nothing but my total cost plus profit. My total cost involve variable cost and the fixed cost and profit is P. If I write it down, my total sales is nothing but selling unit per rupees multiplied by number of units. Similarly, my variable cost is rupees, variable cost rupees per unit multiplied by units plus profit plus loss. And if I take this on the left side, then this is delta minus V multiplied by X equal to profit plus loss. So this is X I will get, the number of produced for profit P, right? This number of quantity I will get. So let's suppose if I have to make profit of 1000 rupees, if I make a profit of 1000 rupees, then I will identify my this also will increase, right? As I need to increase profit, my X also will increase, my production will also increase. If I put profit equal to 0, then whatever X I will get is nothing but your break even point, because I'm at that point I'm having no profit, no loss. So this is, if you see here, this is what we have done. Your fixed cost upon delta minus V is nothing but your X break even point. And if I talk about my sale, what is the amount of sale I need to do for that price, that will be what is selling price per unit multiplied by number of units at break even point. This will be my BEP sale. That's what we told here. The BEP sale is nothing but your selling price per unit multiplied by number of units. Okay. Now to understand this graph, we have some angle of incidence. This theta is there, angle of incidence. So this theta will tell you how much, basically at which total sale lines cut the total cost lines. So total sales lines cuts the total cost line. This is your angle theta. If you have more theta means you will be at better position. You will be selling more. You will be basically it's a slope of selling cost per unit price. If you're having high selling cost, then you will have higher slope. But again, if you're having higher sale price, then you should know that you have to work in a competitive environment. You cannot go beyond certain which is market is not accepting. Then your sale will be less. Okay. Then we have a contribution margin term. So contribution margin basically tells you how much total sale you are doing and what is the total variable cost. It's basically a margin. It will tell you that how much total sale you have made minus total variable cost. So contribution margin, if I show you here, this is the margin of safety is here. So I cannot show in the graph, but contribution margin is nothing but how much you're selling, selling cost and my variable cost. So if I minus this delta minus V into X, that is my contribution margin. It's basically a contribution you're doing for selling, right? That's the whole idea. How much contribution you are making, right? If I'm doing total sale of 1000 rupees, if I'm doing total sale of 1000 rupees and my variable cost is 500 rupees, then my contribution is 500 rupees, right? That's the whole idea. So my sale is nothing but fixed cost plus variable cost plus profit. And if I do sale S minus V, then I have F plus P. So what this contribution margin means, where I'm doing my contribution, I'm doing my contribution to the fixed price and the profit. That's the whole idea. That's why it's called contribution. I'm doing the contribution. If higher the contribution means higher the amount I'm paying to my fixed cost and my profit, right? That's the whole idea of this contribution margin, or it can be told as marginal profit or gross profit, because it has the profit terms along with the fixed cost. That's why it's a gross profit. The higher number of units you will sell, higher the number of units you will sell, higher you will have contribution margin, higher you will have gross profit. Because why are you having more gross profit? Because indirectly you are contributing to the profit and to the fixed cost of the product. Okay. Now if you go on profit volume graph, so let's suppose there is a graph on y-axis, it is profit, and bottom we have loss, and again on x-axis we have number of units of volume of production. Okay, so if I write it down as del S into X into F equal to F plus V into X plus profit, this is a generalized term we are writing, is like selling price equal to fixed plus variable plus profit, right? So if I break this down, I can write this. And if I write down profit is nothing but delta minus V minus F. So let's suppose I did not sell any unit. If I did not sell any unit, my X is equal to 0 initially. If initially I'm not selling any unit, my profit is nothing, my loss, which is F. Whatever I'm investing as a fixed cost will be my loss, right? It's nothing new. As soon as I start selling, my volume of production increasing, my loss will reduce, and there will be point where I will have no profit, no loss. This is nothing but BEP, your break even point, right? This is my break even point. And break even point, I know, is nothing but if I put profit equal to 0, then I will get the value of this. This is my break even point. Number of units. This is number of units. Okay, great. Now we have one more terminology, which is profit volume ratio, which we call it as PV ratio, or we can call it at contribution ratio. It is nothing but it's basically how much contribution you're doing over the sales. For example, uh, for this example only, what we have written. So my contribution margin is for this case is 500, right? And how much sales I'm doing is 1000. So my PV is nothing but, if I write it down, 50% is my contribution ratio. That's the whole idea. How much you are doing contribution in from your sales, right? That's the whole idea. So the term, it is a term used to represent profitability related to sales, and it is a ratio of contribution margin to the volume of sales, right? So PV ratio is nothing but how much contribution I'm doing from my sales, and contribution is going to your profit and your fixed cost, right? That we know. So contribution nothing but S minus V upon S, and I can write down delta minus V by delta, or I can rewrite as fixed plus profit by S. How much profit and fixed cost are associated from the sales price. For example, if my selling cost is 200, my variable cost is 120, my contribution margin is 80, right? And from 80, how much? So from my sales, 80 rupees is my contribution to my fixed and profit. That's the whole idea. So 40% of every 1 rupee sale contribute to fixed and profit cost. That's the whole idea, PV ratio. So higher my PV ratio means higher amount price I will giving to my fixed cost, and higher the amount I'm putting into the profit. That's the whole idea. Okay, next is we have a margin of safety. Margin of safety is nothing but is a difference between output at full capacity compared to output at break even point. Margin of safety we have seen here in the graph. So this is the margin of safety. So let's suppose you sell this much volume of production. Let's suppose you sell at something like XA. So your margin of safety in terms of units will be nothing but XA minus XBEP. Similarly, if similarly for in terms of sales, we have MOBEP sales, and this is some units you sell at some 1000 rupees. Let's suppose this is 5000 rupees. You sell the amount, and how much minimum you need to sell? You need to sell 1000, such that your 4000 is nothing but margin of safety sale. So it will give you and give a track that this much at least you need to sell, so that you should not incur any losses. It's the difference of output at full capacity compared to output at break-even point. Okay, and it will tell you how much actual or expected sales can drop before the business reach it to break-even point, right? We would get to know like 1000 is my break-even point. My sales is 3000 this year, and this year and next year it's 2000. I'm going down, but I should not go below 1000. I need to do some activity. I need to take some decisions so that my sale will go up. So this is margin of safety. So this can be written in terms of value and in terms of units. That's the whole idea. So in terms of sale, in terms of value, I will write it at sale X minus sale at BEP. And sale X is nothing but your delta into X and delta into X BEP, right? If I take delta common, then X minus X BEP will be there. And if I write X BEP, I can write F minus delta minus V, right? If I take this up, then I will form delta minus V into X minus F upon delta minus V. So what conclusion I will get from here? So if I take this delta minus V, if I take this down, this will be nothing but your PV ratio, and the top what I have written is nothing but your profit, right? So I can write it down by profit PV by ratio. That's the whole idea. If I have to calculate the percentage, how much percentage is very simple. Delta x minus delta x BP upon delta x into 100. That will tell you that how much percentage you are above over your break even point. Okay, so now we see what are the changes you can do in break even point. So we know that your S is nothing but fixed, variable, and profit. If you do S minus V is nothing but fixed plus profit. And I can write it down by like this. We know this term we have already seen. X equal to fixed cost. This is selling price per unit and your variable cost per unit, right? Now my first question is, if I increase my fixed cost, then what will happen? I need to see this graph and this equation I need to understand. If I increase my fixed cost, basically, if I increase the fixed cost, my break-even point also will increase. Initially, my fixed cost is 100 rupees and I was selling 10 units at break-even point. If I increase my fixed cost by 200, then definitely my BEP will also increase, right? Because more units I need to sell to incur my fixed loss as well. That is obvious, right? It's obvious. Now next is variable cost increase. If I increase my variable cost, so if you increase your variable cost, then what will happen? If you this will increase, the whole thing will got decrease, right? Because selling constant is constant. The more you increase, the more difference will decrease, and your XBP will increase, right? For example, your variable cost again. If you increase in the variable cost, because variable cost is associated x is we have some x of 10 you need to sell. Now tomorrow you increase the variable cost or variable cost to 200, then definitely your break even point also will increase, because the more number of you need to sell, right, to get the same profit and same what's the same selling point. Next, if what will happen if I sell if I sell your if I increase the selling point. So if I this increase, my whole thing will increase and my x will decrease. So what does it mean? If my selling price, if I'm initially was selling at 100 rupees, tomorrow I sell it for 200 rupees. It's good to know how much higher price I will get into my profit, and my XBP will in that case will decrease, right? That's the whole idea. I mean, from theoretically also you will get to know, and through formula also you will easily understand what is happening. Okay. So let's go through one of the problems from BEP. What it says that a product can be produced by 4 processes. We have four processes: one process, two process, three process, and four process. To produce 4 processes given in order to produce 100 units, we need to produce 100 units. Which process should be preferred? They have given, so tomorrow you are setting up something and you have 4 processes and have fixed cost they have given, variable cost they have given 200, 400, 10, 30, variable cost 3, 1, 4, 2. Now you need to produce 100 unit. To 100 unit you can produce by, if you know your total cost, you need to minimize the total cost, right? In the end, it's a fixed cost plus variable into number of unit. If your fixed cost, for each case you need to find out the value. And whatever the total, whichever is the total cost is minimum, that process definitely you will say. You will not go for process which will take more cost, right? That's the whole idea. So if I calculate total cost for each case, is nothing but 3 into 3 unit into 100 units multiplied with plus 20, I will get 320. For second case, I'll get 140, third case, I get 420, and the fourth case, I will get 230. So I will see the minimum cost I'm seeing on the second process. So my cost is 140 rupees, so I will go with this process. We'll go one more problem on this. A company require product for which they have 3 options as given below. Okay, draw the total cost curve for all 3 processes and find the economic feasibility if 7,000 units is to be produced and process should be preferred and company corresponding cost. So now company is building something, require a product which they have option of 3 ways to build a product. They have automatic machine, they have semi-automatic, and they should simply purchase it from some vendor. So to automatic machine, they have a higher fixed cost, but the variable cost is way less. If you buy a semi-automatic machine, fixed cost is less, and but your variable cost increase. But if you purchase, you don't have to go for fixed cost, because you're not doing it. You are simply buying. Your each variable cost is 10 rupees per unit. Now for 7,000 unit, which process you should follow? Which process? Because again, as an industrial engineer, this is your job to minimize the cost, right? So I will simply put with this variable, I will simply put the graph and we'll see what is happening. So if you put a graph on the y-axis, I'm putting your value and x-axis is number of production, right? So if I see I'm putting one automatic cost, automatic case is 43,000 fixed and then 3 is variable. So I'm doing 43,000 fixed and over and above I'm putting the 3 is the automatic. The slope is less because v value is less. Then we have semi-automatic, which is 16,000 and then 6. Semi-automatic we have the fixed cost and over and above we have your this semi-automatic cost. And third we have purchase by 10 rupees per unit. So purchase means there's no fixed cost, simply you're buying with a higher slope, means higher variable cost. Okay, so if I solve the problems, because I don't know the number of units how much I'm selling. So if I equate this equation, then I will get number of units. This S and A, this will be the units I will get. Similarly, I will get this unit which is P and A, and similarly this and this. So I need to solve all this equation to get number of units. How we will solve it? So for example, I will solve 3x plus 43,000 will be nothing but your 6x plus 16,000. I will get some value x. There's an intersection point. So simply I will plot a graph. So I will put a graph and find the value of all the units. So first I will calculate my this point, which is purchase and semi-automatic. So if I use this formula, I mean calculate the x. So 4,000 will be the number of units where my purchase and my semi-automatic meeting a point. Then I will solve for next point, which is nothing but your automatic and purchase. Then we have 6142, and similarly I will solve for another point which is automatic and semi-automatic, which will go 9,000, right? So my overall objective is how many units I need to sell is 7,000. So my 7,000 will lie somewhere between this point and this point, right? So my this point will be this curve, red portion, and red portion is nothing but semi-automatic. So the whole idea is that if I'm producing 7,000 unit, then I should go for semi-automatic. If I have to produce more than 9,000, then I should go for automatic, because my total cost curve line is this. This is, if I am selling 4,000, then I should purchase it. If between 4,000 to 9,000, then I should go semi-automatic, and beyond 9,000 I should go for automatic sale. These are my total cost at minimum cost, right? So, and if I can find out my total cost for 7,000 unit, it's not the automatic, I'll get 64,000, and for total semi-automatic 58,000, and for purchase it's 70,000. So overall my total cost for sale 58,000 for semi-automatic, that we have seen theoretically and graphically. Okay, so this is all about your break-even point. Going forward, we have topics like inventory, then sequencing, there's a PERT CPM, linear programming. There's a lot of things are there. As an industrial engineer, when you go into a factory or in a plant, you should know that as a production manager or as an industrial manager, you should be capable to handle all those things. Your overall objective is whatever you're producing, you should not make your company at a loss. That's the whole idea. And how you can do it, you need to produce an object, or you need to prepare a method in such a way your total cost should decrease. So that's the whole idea. You should sell at minimum cost and you should generate maximum profit. So this is the whole idea about industrial engineer. And if you like this video, you can always share. And again, it's a demo class on industrial engineer, subject for the GATE examination. And going forward, we will solve more numericals which has come in the past GATE examination. Okay, that's all for today. Thank you all.